Hello. Today we're going to focus on a fundamental principle in physics, which is Newton's second law. Newton's second law states that the change in velocity of an object, Vf minus Vi, divided by the change in time, is equal to the sum of all the forces acting on the object, divided by the mass of the object. This principle gives us the equation we're going to focus on today. Vf equals Vi plus F net divided by mass times delta T. In today's experiment, we're assuming that the net force acting on our object is zero. This does not mean that there are no forces acting on the object, but that the forces cancel each other out. Because F net is zero, the initial and final velocities will equal to each other. Hence, the object is in constant motion. I observed a tennis ball rolling across a table to test out this theory. Here is the video of the tennis ball. I used Tracker to track the motion of the ball and extract position versus time data. I chose the orientation of the axis so that the ball is moving in the negative x direction. If I were to flip my axis so that the ball was moving in the positive x direction, the x values would be increasing, but the graph would still remain linear. The velocity vector would be in the opposite direction but have the same magnitude. I started my frame after the ball was rolled so that it has stopped accelerating. I used the first two position data points to estimate the initial velocity and the initial position of the ball, so that I could create a computational model using these initial conditions. So here we have the initial position of the ball at t equals 0 seconds. The second position of the ball was recorded at t equals 0.033 seconds. We calculate the initial velocity by finding the change in position and dividing by the change in time. The initial velocity of the ball comes out to be negative 0.545, 0, meters per second. With this information, we can make our computer model using VPython. The mass of the ball is 0.057 kilograms. I put the initial position of the ball here and the initial velocity here. We're creating a while loop to predict the motion of the tennis ball. The final position was recorded at t equals 0.933 seconds, so we're focusing on t less than that. We're assuming that the net force in our observation is zero. It is not possible to predict exactly how many pushes and pulls are acting on the object as well as their magnitudes, but we can assume that they cancel each other out. This is Newton's second law that predicts the ball's new velocity. This new velocity is used in the position equation to predict the ball's new position. The computational model in VPython gives us a graph that looks similar to the one from Tracker, as you can see here. As one can see, the observed and predicted positions match with each other almost perfectly. However, in later times, the model overpredicts the position of the ball. This discrepancy is due to the fact that we underpredicted our observed position because the ball was not traveling in a straight line and coming towards the camera, as you can see here in Tracker. In conclusion, Newton's second law is a reliable way of predicting an object's motion.